Welcome everyone to this quick overview on scikit-learn, and we really won't be talking about scikit-learn machine learning models because we're going to be using TensorFlow instead. What we're going to be talking about in this lecture is using scikit-learn for pre-processing, and specifically two things, and that is scaling our data and also splitting our data into train test sets. Let's go ahead and jump to Jupyter Notebook and see the convenience functions that scikit-learn provides for us. Okay, to go ahead and generate some data, I will import NumPy as NP. And then we're mainly going to be using pre-processing with scikit-learn. So we'll say from sklearn pre-processing import, and we'll be importing the min-max scaler. Let's go ahead and create some data. We'll just say np random rand int, and we'll say random data 0 to 100, and we'll have it be 10 rows by 2 columns. So if I take a look at my data, I see here that I have the 10 rows, 2 columns. We can kind of think of this as either features in a data set or labels in a data set, etc. So if I actually want to run this data into a neural network, usually what I should be doing is scaling the data. In order to do that, I can use the min-max scaler. So the way we do this is we create an instance of that min-max scaler. So I'll say scaler underscore model, or really whatever you want to call it, min-max scaler, close parentheses, and now if I check out the type of that scalar model, it is an instance of a min-max scaler. And then what we do is off of this scalar model, we're going to fit it to our data. And fitting it to our data basically allows the model to learn what the minimum value and what the maximum value is for each column. This warning right here, you don't need to worry about it too much. It's just reporting back that it's converting the integers into floating point numbers, which makes sense because we expect these, once they're scaled, to be floating point numbers. Then once we do that, we can go ahead and grab our model and then transform the data. And then once you transform the data, you'll notice what happens is that the minimum value becomes 0 and the maximum value becomes 1, and that goes across each column. So if we kind of scroll up here, we can see here that in my case with this random data, I had my max value for the first column at 92 and the minimum value was at 3. So if we divide each value in this column by the max, 92, we end up getting these results. And that is what the min-max scaler does. There's other ways of normalizing your data, but for most of our cases, since we're dealing with pretty basic data sets, the min-max scaler will be enough. Now technically, I could have done this in one command. Instead of saying fit to the data and then transform the data, the scalar model also has a fit transform. And if you run that on the data, it performs both those steps at once. Depending on what situation you're in, what you're usually going to do is you're going to fit to your training data and then transform your training data and then transform your test data. And the reason for that is because you don't really want to cheat by fitting to your test data as well as your training data, because you don't want to assume that you're going to know what your test data is going to look like. So typically you fit to your training data and then you transform to your test data and your training data. But the model itself, this scaling model, has only been fitted to your training data. All right, let's go ahead and kind of show an example of a train test split. So I'll import Pandas for this. I'm going to create a data frame. So we can imagine we just read in some CSV file. So we can say pd.dataframe to create a data frame, and I'm going to say the data is equal to np.random.randint. We'll say 0, 101, and then 50 by 4. And in fact, let's actually just grab that entire thing and put that in a new cell, and we'll have that be my data. So if we take a look at my data, it's just these integers here. It's 4 columns by 50 rows. So scrolling down here, that's going to be the data I pass in. And you could put that whole command in one line, but this makes it a little cleaner here. And then let's go ahead and if I just pass this in, and I take a look at data, and if you want, you can call this df, that way it's a little clearer. So we'll say df is equal to pd data frame there, and if I take a look at df, so now that I'm viewing my data frame, I can see here that Pandas has auto-named these columns to be 0, 1, 2, 3. What I can do to make sure those columns have names is I can provide a list of names. So let's imagine this as a data set. So I'll have 3 features, F1, F2, F3, and then some sort of label. So I can already tell this is a supervised learning problem. I have 3 features and I'm trying to predict this label. So now if I take a look at my data frame, now the columns are named, so 3 features, and then the label column. Now let's imagine this is our entire data set, and I want to split it into a training set and a testing set. The way I can do that is through the following method. If I scroll down here, I can say my x, that is my features, is equal to data, and then I pass in a list of the columns. Only the feature columns, that is. So F1, F2, F3. So, whoops, let me make sure I pass in df here. There we go. So now if I take a look at x, it's only the feature columns. And I'm going to do a similar process for y, for the labels. We'll just say y is equal to df label. Run that, and if I take a look at y, it's just that label column. Okay, so now that I have my features, my actual data, and then the label that I'm trying to predict, I can do a train test split. So you'll say from sklearn.modelSelection import train test split, run that, and then what I like to do is call train test split, do shift tab here, and then you can expand this to see the actual documentation, and if you scroll all the way down, there's a nice little example that you can kind of copy and paste from, and it's this one right here, xtrain, xtest, ytrain, and ytest. Copy that whole command, and then we can actually overwrite it here and put this all on one line. Let me zoom out a little bit so we can see the whole thing. So what does train test split actually do? Well, you pass in your feature columns, and then you pass in your label, and then it's going to ask you what the test size is going to be. So it's asking you what percentage of the data do you want to go to the test set. A really common value here is 30% or 33% should be your test, 70% should be your training. And again, this is a very situation-specific number, so there's no right or wrong answer here. Sometimes a 50-50 split makes sense. And then the random state is basically for repeatability. Just like we had NumPy random set seed, we can do a seed here as well. That way you can always make sure that you get the same random splits. So you can say 101, 42, etc. It's up to you. And then you get back these 4 variable results. You get back an xtrain, an xtest, a ytrain, and a ytest. So if I run this, and I check out the shapes of these guys, whoops, xtrain, check out the shape, notice I have 35 rows by 3. So that means this is the actual xtrain, so that is the feature data for the training set. And if I take a look at xtest, whoops, let's go ahead and take a look at the shape here. Then I have 15 by 3. Notice that it's smaller because this is the feature for the test set. So the basic idea here would be once I actually have my neural network model working in TensorFlow and I wanted to do some sort of training process for supervised learning, I would feed it in the training sets for xtrain and ytrain. And the model would try to basically build some sort of understanding of how the X training features are able to predict the Y training labels. Once I have that, then I can evaluate my model by feeding it the X test data, and then it will try to predict what those labels should be. In order to do the full evaluation, I can then compare those predicted values to the true Y test values. And that's the reason for a train test split. And we're going to see this later on in the course. Okay, that's really all we need to know about SciKit Learn. And as a quick note, SciKit Learn is actually its own machine learning library for Python. It's one of the most popular out there, but it doesn't support the deep neural networks that TensorFlow can do, so which is why we're not really going to be using it in this course. If you're interested in some of those other SciKit Learn machine learning model methods, you can check out that Python for Data Science and Machine Learning Bootcamp course. Okay, thanks everyone, and I will see you at the next lecture.